All right, part two here. Um, we've still got some of these shapes. We're going to be using the formulas from the page before. And so here we go. We need to write an algebraic expression for the volume now. Okay, so we've got the volume of a cone. And sorry, it printed kind of weird here. This is the volume of the cone. 1/3, oh, sorry, you can't see. 1/3 pi r squared h. Okay, so the volume is 1/3 pi r squared h. All right, so here we go. The volume is 1/3 pi times the radius, which is x, squared times the height. And the biggest thing that I'm saying is some of you guys just aren't protecting with parentheses. Understand that x plus y here is the whole entire height, so that has to be protected with some parentheses. Okay, so then we've got 1/3 pi x squared, okay, and then that x squared you actually have to distribute inside of there. So if you've got x squared times x, that's x cubed, okay, plus x squared times y. So actually, hold on, let me write this out a little bit better here. So if this is x squared, you have x plus y, okay. Now think of this as all, one term here. So you've got all of this one term distributed to the x and all of this one term distributed to the y. So let's think of our numbers first. We still got that 1/3. Okay, we've still got a pi, and then x squared times x is x cubed. And then plus, you still have got the 1/3, you still have the pi, but now x squared times y is just x squared times y. And that's all that you can do. You just stop there. You don't think about anything else. You just stop. Okay? Okay, great. Here we go. The volume, this is a cylinder, okay? And the volume of a cylinder from that first page is equal to pi r squared h. Okay? So the volume is pi times the radius, which is 2x squared, times the height, which is 3x plus 2. And now we simplify, which is equal to pi times 2x squared. Well, 2 squared is 4, and x squared is x squared, times 3x plus 2. Okay? And now, again, this can be thought of as 4 pi x squared. So I just moved that pi in there with it. And now we can distribute. So 4 pi x squared times 3x, well, 4 times 3 is 12. There's only one pi, but then you've got an x cubed, okay? And then 4 times 2 is an 8, and there aren't any other variables there, so that just stays like that, and that is your final answer. You just wait there, okay? Cool. This next one is really interesting because you've got another cone here. But not only do you have a cone, but you have a cone inside of a cone that's being cut out. So it's kind of like an ice cream cone, if you will, an upside down ice cream cone with the middle of it cut out so that we can fill it with ice cream. Yum. Okay, so what we're going to do is we're going to take the volume of all of the cone, and then we're going to punch out or subtract out the middle. Okay, so from the first page, the volume of a cone is 1/3 pi r squared h. So we've got 1/3 pi. The radius of the big cone, okay, so that's what I'm doing first. The radius of the big cone is 2x plus 2x, which is 4x. And then that's got to be squared, times the height, which is 5x. Okay, which is equal to 1/2 of pi times 4 squared is 16x squared times 5x. Oh, not 1/3, sorry, 1/2, or not 1/2, 1/3. Which then gives us 1/3 pi times 16 times 5 is 80. So we've got 80x to the third power. Okay? 80x to the third power. And then what we can do is we can say that that's 80 over 3. I just combined the 80 and the 3. but then you would keep the pi x cubed, just like that. So that's the volume of all of the cone, but we want to now punch out the middle of the cone. So we've got 1/3 pi, that radius is just 2x squared, times the height, which of that height is 3x. Okay, so that gives you 1/3 pi, 2x squared is 4x squared, times 3x, which then gives you 1/3 pi times 4 times 3 is 12. Then there's 3 x's. And 1/3 of 12 is 4, so we've got 4 pi x cubed. So if we want to find the total, we take 80 divided by 3 pi x cubed minus 4 pi x cubed. And 80 thirds minus 4, if you plug that into your calculator, you're going to get 68/3 pi x cubed. And that's the volume of the ice cream cone. Lots of just knowing how to manipulate things. I feel like, plugging and chugging into a formula isn't too hard, but, learning how to manipulate it otherwise is a little bit more difficult. Okay? All right, moving on. Number 10, you're making a fence for your garden, the length, and we're going to pretend it's a rectangular garden, by the way. Okay, so we've got our garden here. Garden. The length is 5 less than 2 times the width. Okay, so if we let the width be x, the length is 5 less than 2 times the width. So 2 times the width minus 5. Okay, so let's write a polynomial that represents the perimeter. So we've got 2 of the x sides plus 2 of the 2x plus 5 sides. So if we distribute, we get 2x plus 4x plus 10, which then gives you 6x plus 10. So that's the perimeter, okay? So now write a polynomial that represents the area. Okay, well that's just base times height. So x times 2x minus 5. Distribute, so you get 2x squared minus 5x. And there's nothing else you can do. Those are unlike terms, so you just stop there. Okay? So now find the perimeter and area of the garden when the width is 8 feet. Okay, so I gave you the width, which is your x value. So if x equals 8, to find the perimeter, we use that top equation. 6 times 8 plus 10, which is 48 plus 10. Oh, wait, minus 10. What did I do wrong? Oh, I know what I did wrong. I'm so sorry. Minus 5, which would create a minus 10. Sorry about that. Which is the same here, except it's just a minus sign. And 48 minus 10 is 38. The unit on that is feet. Okay? For the area, we use this one up here. So 2 times 8 squared minus 5 times 8. And if you plug that into your calculator, you get 88 square feet. Okay. Not too bad, just knowing how to manipulate things. Okay. All right, number 11, we're going to kind of change gears here. We've been adding, subtracting, and multiplying for the entirety of this packet, but now let's talk about some factoring things. Okay, so number 11, once you do identify the value of c, that would make the trinomial factorable using the perfect square pattern. Okay, so what that means is when we factor this, we want to end up with two binomials where this is x and x, and whatever this number is and this number is, those are the same. That's what we call a perfect square trinomial. Okay, we haven't talked about that a lot, but that's what this is. So we need to find whatever that c value is that makes this number and this number the same. Well, you know that these both have to be plus signs, right? And you know that we have to get to 24 through addition. So we need a number that when we add it to itself, we get to 24. Okay, and there's lots of ways you can get to 24, right? 23 and 1, 22 and 2, 21 and 3, 20 and 24, right? But we need it to be the same number. And the number that would work here is 12 and 12. 12 plus 12 gets us to 24. Okay, so that's what it would be if it were factored, but the question wants us to find the C value. So in order to do that, we need to multiply those two, right, if we were FOILing. And so the C value that you would need is 144. Okay. B is very similar. Okay, but this time we've got a subtraction sign. So you know that you've got to have x and x. You know that since this is positive, both of the signs have to be the same, and because this is negative, they have to be a negative, excuse me. Okay. And so the number that you could add to itself to get to 10 this time would be 5 and 5. So that means that that C value out there has to be a positive 25. And that's where we wait. Okay? C and D are a little bit more difficult, and that's because we have an A value out here that is not 1. Okay? And so you know that the number one rule of factoring is to take out a greatest common factor. So here you notice they both have a 6 in common. Okay? So we're going to assume that that can be taken out of this last one as well. Okay? And so if you take a 6 out, you're left with x squared minus 6x plus you're going to have some number there. We don't know what it is. It is not the C value, though. It's related to the C value, but if we're going to divide that C value by 6, it's obviously not going to be the same number. Okay? So then we have to think, okay, well, in that case, if we are to factor this, we need two numbers that are the same that would get us to 6. So that would be 3 and 3. We know that we have to be minus and minus, okay? So that means that the number that needs to go there is 9, which means if we work backwards, 6 times 9 is going to give us a C value of 54. Okay? Nothing too crazy here. Nothing too nuts. Just a little confusing. Same thing on D. This time we can take out a 3. So we're left with x squared plus 8x plus some number. And then we split that up into two binomials.
Just a reminder that the art club was canceled for this afternoon.
Oh, dang it. I was totally going to go.
Students who are staying after school should be, the only students staying after school should be the students that are with a staff sponsor or a coach at this time. Students who are staying after for your ride, you need to be in room B103. This is a change. Instead of you waiting in the student commons for your ride, you do need to wait in room B103. All other students, you need to make your way home. So again, all students who are staying after for sports practices or other school supervised activity, you should be with your staff sponsor or coach at this time. Art club was canceled. Students, if you're waiting for a ride, you need to wait in room B103. This is a change. Instead of the commons, room B103. All other students, you need to make your way home. Thank you.
Excellent. Okay. Anywho's, so we need two numbers that get us to 8, which in this case would be 4 and 4. We know we have to be plus and plus. So that means that number has to be 16, which means if we were, oh my gosh.
Elijah Akins, please report to the front lobby. Elijah Akins, please report to the front lobby.
All right, so the C value here is 48. Okay. Those might take a few more thinking. You might need to rewind that part. Okay. Similar thing here on number 12. What are all the possible values for B in which 3x squared plus bx minus 8 is factorable using only integer coefficients? Okay, so what this means is if we were to factor this right here, what are all the possibilities that B could be? Okay, well, let's just start with what we know has to be true. What we know has to be true here is that we have to have a 3x and an x. That is the only way we get to 3x squared. Okay, but now let's look at 8. Okay, and it's a negative 8, but we'll talk about that in a second. With this 8, we can have 1 and 8. We can have 2 and 4, right? But because this is negative, we can be negative 1 and 8, or we could be negative 8 and 1. and we can be negative 2 and 4, or we can be positive 2 and negative 4. And not only that, but because we have here a 3 out in front, because you have a 3 out in front, the order of it matters. Okay, so let's just start with negative 1 and 8. Okay, so minus 1 and positive 8. Okay, let's see what we get. So 3x squared, so 3x plus 8 would be a 24x minus 1x minus 8 would give you 3x squared plus 23x minus 8. So a possible value for b could be 23. But hey, watch this. What if we had 3x plus 8 and x minus 1? So you still have a positive 8 and a negative 1, but this time you've just switched them. So you get 3x squared minus 3x plus 8x minus 8. Okay, so then you'd have 3x squared plus 5x minus 8. So another value could be 5, right? We're looking for that b term. Okay, so now what if we did a positive 1 and a negative 8? So 3x plus 1 and x minus 8 would give you 3x squared plus 24x plus x minus 8. Oh, sorry. This should be a negative 24x. So then you get 3x squared minus 23x minus 8. So you could have also had a negative 23bb. And then you can also do the same thing here with a 3x minus 8 and then an x plus 1. So you would get 3x squared, 3x minus 8x is a negative 5x minus 8. So negative 5 could also be an option, okay? So I've just taken all the possibilities of 8 and 1. I want you now to go through and do all the possibilities of 2 and 4. Okay, so there's 1, 2, 3, 4, 5, 6, 7, 8 total possibilities. I've given you half of them. I think you can go through and find the other half. Okay? So you can check that with me in class. All right, last page here. Write an algebraic expression for the shaded area of the figure. Recall that the height of an isosceles triangle bisect. Okay, so anywho's, we're going to do this actually a little bit differently. The easiest way to do this is just to find the area here of this trapezoid. And the area of the trapezoid is 1/2 of base 1 plus base 2 times the height. We did that in class one day. Okay, so we've got 1/2 of the first base is this down here, which is all of that combined, which is 3x plus 3 plus base 2, which is x plus 5, times the height, which is x plus 4. So if we simplify now, we've got 1/2 of, this is 4x plus 8 times x plus 4. And I'm actually going to distribute the 1/2 first. So that gives us a 2x plus 4 times x plus 4, and now we can distribute. So you get 2x squared plus 8x plus 4x plus 16, which then simplifies to 2x squared plus 12x plus 16. And that's where you stop. Okay. This next one is a bit different in terms of the fact of now we've got a rectangle and we're going to punch 2 triangles out of it. Okay, so let's first just talk about the area of this rectangle. The area of a rectangle is the base times the height. The base here is 3x. The height is 2x. So 3x times 2x, the area of that square is 6x squared. Okay? So that's kind of where we are. Now we got to think about these triangles. Okay, there's 2 of them. We've got that top one and we've got the bottom one, and they're different sizes. So let's talk about this one first. Okay, to find the area of the triangle, we have 1/2 of the base, which is 2x, times the height, which is x. Okay? And so with that, that's like 1/2 of 2x squared. All right? And 1/2 of 2x squared is just x squared. So this part up here is x squared. Okay? Excellent. So then for this one down here, we know that we need 1/2 of the base times the height. So you've got 1/2 of x squared. And so that's just 1/2 x squared. There's nothing you could do there. So to find the area of that shaded region, we take 6x squared, we subtract off this top x squared, and then we subtract off 1/2 x squared. Well, 6x squared minus 1x squared is 5x squared. 5x squared minus 1/2 x squared is just 4.5 x squareds. And that's where you would stop. Okay? Sweet. Okay. So here we go. Last one. The side of a cube is represented by x feet. Okay, so we want to write a polynomial that represents the volume of this cube. Okay, so I'm going to start by drawing a picture. So if I have a cube here, okay, cube. All right, the side lengths are all x's. The volume is the base times the height times the width, which just simplifies to x cubed, and that's really all that you do there. Okay, nothing super duper nutso there. All right, write a polynomial that represents the surface area of the cube. Okay, so the surface area, we did this one earlier. The surface area, well, one face of that cube, that area is x squared, right? Base times height. But there's 6 faces of that. So the surface area here is 6x squared. Okay? Now here's where things get interesting. You increase each side of the cube by 1 foot. Write a polynomial that represents the new volume. So instead of this being x, each side is increased by 1. So that means that the volume is x plus 1 times x plus 1 times x plus 1. And a lot of you just want to do x cubed plus 1, and that's not how this works, okay? So what I would encourage you to do is ignore this and FOIL that first and then distribute out there. Okay? So we've got x squared plus 1x plus 1x plus 1, which turns out to be x squared plus 2x plus 1. Okay? All right. So, but the problem here is that we still have to distribute to that last x plus 1. So then we distribute and we get x cubed plus x squared plus 2x squared plus 2x plus x plus 1. So then you're left with x cubed plus 3x squared plus 3x plus 1. And there's nothing else you can do. That's the new volume of the cube. So it looks really different. Just increasing each side by the cube by 1 foot does that whole entire thing to it. Crazy. Just crazy, I tell you. Okay? All right. You double the length of each side of the cube. Okay, so now instead of increasing by 1, we're going to double the length. So that means that now the lengths are 2x. Write a polynomial that represents the new surface area. Okay, well, if each side is 2x, the area of one of the surfaces would be 2x times 2x, which would be 4x squared. But there's 6 faces of that, so we multiply that by 6, which gets us to 24x squared. That's the new surface area. Okay? All right, I know that if you listen to all of that, you probably are sick and tired of hearing my voice. So if there are still questions, if you're still confused, send me a message through Remind, or see me in class if I am there. Yeah, good luck. Hopefully this helped.